Section 1.1 is variables, grouping symbols, and expressions. The most basic concept you can get in algebra is the idea of a variable, meaning representing an unknown. So here's an example. If you were to go to a lake and rent a kayak, the rental charge is $15 per hour. The amount you'll have to pay depends on how long you use the kayak for. I guarantee you've used some sort of algebra in your life before without even knowing you were using algebra. So if you were going to use the kayak for 1 hour, you would have to pay $15. If you were going to use it for 2 hours, you would pay $30. If you were going to use it for 4 hours, you would pay $60. All I was doing there was multiplying the number of hours times the amount it costs per hour. So what do you think an equation, if I let the number of hours be equal to h and the rental charge be equal to c, what's an equation we could use to represent this cost? I could say the charge, how much I'm going to have to pay, is equal to $15 times the number of hours that I'm going to use the kayak. 15 is my known piece, it's what's changing. Hours is number of hours is changing, and the rental charge is changing based on the number of hours. So we're going to fill in these blanks here, just some vocab use. A variable is a symbol used to represent one or more numbers. The numbers are called the value of the variable. So whatever number is being represented, it's the value of the variable. If an expression contains only variables, it is called a variable expression. An expression that names a particular number is called a numerical expression. We show that two expressions have the same value by using an equal sign. So expression, when we use this language, an expression, no equal sign. An equation has an equal sign. Okay, so here we're going to evaluate the expression in these examples. Notice there's not an equal sign in this expression. These are expressions, not equations. When we evaluate an expression, we're going to take a specific value of the variable, plug it in for the variable, and then simplify. And we're going to have to use our orders operation, make sure we're respecting PEMDAS, or please excuse my dear Aunt Sally, however remember that. So here I'm going to copy my expression, which is 3a plus 2. And then instead of the a, I'm going to plug in a 5. And that came from this right here. They're telling me if a was 5. So this is saying if the cost of the kayak was 3a plus 2, that was the expression we could come up with, we'd be renting the kayak for 5 hours here. That's our value of the variable. And then I just simplify. So 3 times 5 is 15 plus 2, the whole thing simplifies to 17. You'll notice that the example next to it doesn't have a value of the variable to plug in. There actually isn't a variable. So what you're just doing here is respecting your order of operations and simplifying. So parentheses comes first. 42 divided by 6 is going to leave me with 7 plus 8 leaves me with 15. That would be my final simplified answer here. The bottom two are very similar to the ones above them, so you can try those ones out on your own after the video. So when we talk about grouping symbols, we are talking about our order of operations. So one thing you might have heard, keep in mind the order of operations. People use all sorts of different acronyms to help them remember this, but they are parentheses, exponents, multiplication, right, as a little X or a dot, division, addition, and subtraction. This should all be a review. Right, your order of operations, PEMDAS, please excuse my dear Aunt Sally, whatever you want to call them, this is the order in which you complete things. So you start with your parentheses and simplify inside. Then you look for an exponent, move to the exponent. Multiplication and division, these ones you can go left to right, or you can start with multiplication and do division. And the same for addition or subtraction. These ones are interchangeable, whatever one comes first, but you should get the same answer if you do it the other way as well. So these ones, this is just an example showing you that order matters. First thing here, I'm going to do the parentheses that comes first. So I'm doing 5 minus 3, which leaves me with 2. Now I multiply 6 times 2, leaves me with 12. So it mattered that I did the subtraction inside the parentheses first, as opposed to 6 times 5, which is 30, minus 3, leaving me with 27. Notice those are two totally different answers. It doesn't just apply here, it applies anywhere. Make sure you're following order of operations. So what you see when you're doing 3 times x plus 1 plus 5, what you're really doing is you would add, this will be your first step, x and 1. Then you would multiply the sum by 3, and then you would add 5 to the product. If your vocab is a little rusty in terms of product being the answer of multiplication, sum being the answer of addition, you need to brush up on that. Here's a more in-depth evaluation question. It says evaluate 5x plus y over 3x minus y if x is 3 and y is 8. So I'm going to get this one started for you guys, and you're going to finish it on your own. I'm going to copy my original. And then I'm going to plug in, anywhere I see an x, I'm going to plug in a 3. And anywhere I see a y, I'm going to plug in an 8. So I really have 4 times, I'm going to put my x there. And we said x is 3. And then anywhere I see a y, I'm going to put an 8. And I'm left with 12 plus 40 all over top of 9 minus 8. 12 plus 40 leaves me with 52. 9 minus 8 leaves me with 1. This whole thing simplifies to 1. So I evaluated the expression, and it's simplified to 52. That's the language that you're looking for there. Evaluate when you plug the terms in, and then simplify once you've plugged them in and worked all the math out. All right, we're going to continue on to equations. An equation is formed by placing an equal sign between two expressions. This is something I talked about earlier. What is the difference between an expression and an equation then? An expression, no equal sign. An equation has an equal sign. It's really as simple as that. Sentences that contain variables are called open sentences. Examples of this: 5x minus 1 is equal to 9. It contains a variable. It's an open sentence there. Another example, could look at 2x plus 7 is equal to 19. Okay? The given set of numbers that a variable may represent are called the domain. That's your x values of the variable. It can be written using bracketed numbers, so our domain could be these 3 numbers. We're looking just at those ones. Or you could write x such that x is not equal to 2. That could be a representation of your domain, if 2 was the only number that wasn't included. You won't see something like that until later when we get into rational expressions, and you can't have certain values in the denominator. For now, let's look at where this is going to be applicable to us. It says the domain of x is 1, 2, and 3. Those are the only values we're looking at here. Is the equation 5x minus 1 equal 9 true for each value in the domain? Well, to figure this out, I'm going to set up a little chart here. So I'm going to put my work in the middle, which is 5x minus 1 is equal to 9. I'm going to put my x's over here. That's my domain. I'll put 1, 2, and 3. And I'm going to see, I want these numbers to be equal to 9. If these numbers over here are not equal to 9, then that value isn't true for the domain. It didn't make the equation work. So I plug in 5 times 1 minus 1, is that equal to 9? 5 times 1 is 5, minus 1 is 4. It's not equal to 9, so 4 not equal to 9. 5 times 2, right, is 10, minus 1 is 9. 9 is equal to 9. 5 times 3, 15, minus 1 is 14. 14 is not equal to 9. This is a no, this is a no. So really, only 2 is true for the domain. 2 is the only value from the domain that makes the equation true. Any variable that turns an open sentence into a true statement is called a solution or a root. All of the solutions of an open sentence put together are called the solution set, and each is said to satisfy the equation. If it makes it true, we say, oh yeah, that does satisfy the equation. So 2 satisfies the equation 5x minus 1 equals 9, meaning it makes it work. So this example is similar to the one above. You would have to decide for what values of the given domain would this equation be true. So you'd plug in 0, 1, 2, and 3. I'll get a chart set up for you guys, and you guys are going to finish this one out on your own. So I'm going to plug in 0, 1, 2, 3. There's my x's in my domain. I'm asking myself, is it true? Y times y minus 4 is equal to 3. I'll do the first one. 0 times 0 minus 4, is this equal to 3? 0 minus 4, negative 4 times 0 is 0. Not equal to 3, not part of my domain. So you would need to do 0, 1, 2, and 3. These are like the ground rules, the basics of working with algebraic expressions and equations. It's really important that you understand how a variable works and get the language down, because we're going to be using it a lot, not only here, but in geometry, algebra, pre-calc, calculus, everything like that. So understanding the vocab is key. Understanding how to evaluate equations is also key.